Okay, so let's solve the insert into a binary search tree problem on LeetCode. It's classified as medium. You are given the root node of a binary search tree, BST, which is very important, and I'll discuss why in just a moment. And we're also given a value to insert into that tree. We have to return the root node of the BST after insertion. It is guaranteed that the new value does not exist in the original BST. So why is it important that we're working with a BST? That's because of how BSTs work. If we take a look at this example, for any BST at any given node, the values to the left of the BST are going to be less than that value, or the node value, and the values on the right are going to be greater than the node value. And this principle is applied throughout the entire tree. So if we take a look at node 2, the values on the left of 2 in this example are 1, which is less than 2, and on the right it's 3, which is greater than 2. But if you also notice, 3 is less than 4 because it's on the left side of the tree. And at node 4, we can see that 7 is to the right of the tree because it's greater than 4. And if we take a look at this example after the insertion, we can see that 5 is on the right side of the tree. Therefore, it has to be greater than the root node, but it also has to be less than the node that comes before it because it's on the left side. So the way we're going to solve this is similar to any other tree question, or most tree questions, and that's through recursion. So what we're going to do is we're going to create a helper method, and we're going to call it, well, what it's going to return is a tree node, because that's what they want us to return, and that's called insert. And what it takes as parameters is a tree node, or let's just call it node, and an int val. What's going to happen is, well, since we're working with a tree problem, like in any tree problem, we need recursion, and for recursion, we're going to need a base case. In this case, what we want to do, what I hope to do, is I want to insert our node when we find a node that's null. So to explain that better, I'm going to keep scanning through the tree wherever my value should be, and we'll see that in just a moment. But as soon as I reach a null node, so for example here we need to insert 5. Is 5 greater or less than 4? It's greater, so it's supposed to be on the right. Then we see the 7. Is 5 greater than or less than 7? It's less, so it has to be to the left of 7. And originally 7.next is null, so this is where we're going to insert our value. So our base case would be if node is equal to null, if node is equal to null, then we're going to return a new tree node, which is going to be the value we're inserting, and we're going to give it a value, which is val, and it's going to point to null and null. So basically 5.left is null and 5.right is null, obviously. Okay. So now what we need to do is, well, since it's recursion, we need to call the method itself, and how we're going to do that is like this. Remember I said it's a BST, so values on the left should be less than the value at the given node that we're on, and values on the right should be greater than the given value that we're on. So if whatever value they gave us is less than or equal to node dot val, because I just want the value of the node, then node dot left is equal to insert, which is the method we just created, node dot left and val. Otherwise, if val, or not otherwise because we want to check both conditions, if val is greater than or equal to node dot val, then node dot right is equal to insert node dot right with val, and then we're going to return node. So that's the full code. Oh no, actually it's not. So here in the main method, we actually have to call our function. So insert that takes root and the val. Okay, let's run it and see if it works. Let me just zoom out, submit. Oh, my bad. Okay, let's take a look. Okay, perfect. So let's go through a quick example to make sure the point is we got the point across. So first of all, we're given a tree node root and an int val. In this example, 4 is our root and our val is 5. Okay, so we're calling our method, we're returning our method call, whatever this method returns, and we gave it the parameters root, which is the tree node 4, and the value, which is 5, which is what we want to insert. Alright, so first thing we check is if our node, which is currently our root, which is 4, is that null? No, obviously not. It has a value and left and right pointers. So we're gonna skip this. Then we're gonna check if value, which is 5. Is 5 less than or equal to node.val? Is 5 less than or equal to 4? No, it's greater. So we're gonna go to this statement. So we know that we're going to go to the right side of our tree, access the right subtree. So if 5 is greater than or equal to node.val, then node.write is equal to the, we're calling our method insert and we're giving it the parameters node.write, which is now 7, and our value, which is 5. We go back here, is 7 null? No, so we're going to skip it. Is 5 less than or equal to node.val, which is now 7? Yes, it is. So we're going to look at this method. So node.left is now going to be equal to the result of insert node.left and val. So now we're at the null node because 7.left points at nothing. And once we call this method insert node.left, which takes the parameter null and val, we go back up here and we check, is node equal to null? Yes. So we're going to return a new tree node with the value in the given, and it's going to point to left. It's going to point to null on the left, and it's going to point to null on the right. And so if you keep returning back, once we're at 7, node.left is now going to point to this, and then if you go back further, 4.right is going to be pointing at 7, and 7.left is going to be pointing to our tree node, the one we just created. And yeah, so that was the BST problem on LeetCode. I hope you found that helpful, and thanks for watching.